There's a scene in the 1993 movie Jurassic Park that shows a Tyrannosaurus rex attacking a herbivore and tearing it apart, spewing blood everywhere. But how much blood would have been circulating in the bodies of the most well-known and popular dinosaurs? And what kind of heart and circulatory system would have been necessary to pump all this blood throughout their massive bodies? Let's answer those questions, as well as compare how many humans it would take to have as much blood as a single individual dinosaur. The answers are nothing short of amazing. In the 1993 movie Jurassic Park, there's an intense and memorable scene where a flock of Gallimimus, depicted as small, fast-moving herbivorous dinosaurs, is ambushed by a Tyrannosaurus rex. Dr. Alan Grant and two children, Lex and Tim, are observing the Gallimimus as they run in a large group across an open field. Suddenly, the flock changes direction, showing signs of panic. As the main characters realize something is wrong, the Tyrannosaurus rex bursts from the trees, chasing the Gallimimus. The camera captures the speed and agility of the smaller dinosaurs as they desperately try to outrun the predator. However, the T-Rex is faster and stronger, and within moments, it catches one of the Gallimimus, clamping its powerful jaws down on the smaller dinosaur. The others scatter as the T-Rex stands over its prey, shaking the Gallimimus before it begins to feed. The scene exemplifies the awe and terror of what it would be like to see these prehistoric creatures in action, highlighting the sheer size and power of the Tyrannosaurus rex. Yet Tim can't help but remark, "So much blood," which begs the question, how much blood would there be at such a kill scene? Estimating the blood volume of extinct animals is challenging, but scientists can make educated guesses based on factors like size, body composition, and metabolic rate. Although the prey dinosaur in the movie was identified as Gallimimus, a real Gallimimus may have differed drastically from its depiction. Gallimimus was a large, bird-like dinosaur that lived during the late Cretaceous period. It was a member of the Ornithomimidae family, which is often referred to as ostrich dinosaurs due to their resemblance to modern ostriches. This image helps us to remember this species and recall its characteristics as necessary. Gallimimus was one of the largest members of the Ornithomimidae family, reaching extreme lengths of up to 8.5 meters or 28 feet, but more typically 20 feet. 28 feet is about 5 feet more than a three-point shot in basketball, so Gallimimus was not a pushover in real life. It was therefore probably more of a substantial meal than a snack as shown in the movie. It indeed lived at the same time as T-Rex, making this predator versus prey relationship an accurate representation. It could have been 1.9 meters or 6 foot 3 inches tall at the hip, thus towering over Lex and Tim and likely Dr. Grant too. As far as appearance, Gallimimus probably looked dangerous but would have been relatively harmless unless you were caught in its path as it ran. It had a long neck, a small toothless head, and a long slender tail. Its limbs were long and powerful, making it a fast runner. We think it could run as fast as 42 to 56 kilometers per hour or 29 to 34 miles per hour. Feathers are always a fun topic for debate in the dinosaur world. Although there is no direct evidence, it is believed that Gallimimus was covered in feathers, like other ornithomimosaurs, and thus the movie departs substantially from reality. If accurately portrayed, the flock in the movie probably would resemble a bunch of monster chickens running together, which is somehow more terrifying than what was actually shown on screen. The fact is that the very name Gallimimus means chicken form, and it's appropriate because of the shape of the vertebra of the animal. It was a lot like modern chickens. Gallimimus also had a beak that was similar to a modern duck's beak. This suggests it may have been an omnivore, feeding on a variety of plants and small animals. Like modern animals, dinosaurs were complicated with many opportunistic feeding patterns. Okay, so given all these facts and knowing that a typical Gallimimus could weigh 400 to 490 kilograms or 880 to 1,080 pounds, how much blood could we expect to see splattered everywhere? Gallimimus, as a large, fast-moving theropod dinosaur, likely had a blood volume comparable to that of modern birds. Given its bird-like physiology, birds generally have around 5 to 7% of their body mass as blood. Assuming the Gallimimus weighed around 440 kilograms or roughly 970 pounds, its blood volume would likely be around 22 to 31 liters or 5.8 to 8.2 gallons. This estimate is based on the proportions and general physiology shared between birds and dinosaurs like Gallimimus. Overall, Gallimimus was a fascinating dinosaur with a unique appearance and lifestyle. Its adaptations allowed it to thrive in the diverse ecosystems of late Cretaceous Asia. If it's not too shocking for you, here's a final fact that will crush your childhood dreams about the first Jurassic Park movie. Note that Gallimimus and Tyrannosaurus rex probably would have never met in real life. They simply lived too far apart. Gallimimus was all over what is now Asia, while Tyrannosaurus rex was in North America. Gallimimus would have encountered a Tyrannosauridae, however, in the form of Tarbosaurus. You can check out our video about Tarbosaurus from a link in the description. But what are some other well-known dinosaurs and their approximate blood volume? For convenience, let's just say that there are 4 liters for every gallon, so multiply all these numbers by 4. That isn't precise, but close enough for our purpose. Let's start with the Tyrannosaurus rex. As one of the largest carnivorous dinosaurs, T-Rex likely had a massive blood volume. Estimates suggest it could have had anywhere from 100 to 200 gallons of blood in its body. Let's think about one of the most common plant-eating dinosaurs, the Brachiosaurus. This sauropod dinosaur was one of the largest land animals ever to walk the earth. Its massive size meant it would have required a correspondingly large blood supply. Estimates suggest its blood volume could have been as high as 500 gallons or more. The iconic Triceratops is always a dinosaur fan favorite. While smaller than sauropods, Triceratops still had a substantial body size. Estimates suggest its blood volume could have been around 100 to 200 gallons. No list that relates back to Jurassic Park could be complete without a velociraptor. However, it was likely smaller than depicted in the 1993 movie. As a smaller theropod, Velociraptor would have had a much smaller blood volume than the larger dinosaurs. Estimates suggest its blood volume could have been around 10 to 20 gallons. Finally, let's salute the spikes of the Stegosaurus. This herbivorous dinosaur had a distinctive appearance with bony plates on its back. Its blood volume would have been influenced by its size and metabolic rate. Estimates suggest it could have had a blood volume of around 100 to 200 gallons. These are rough estimates based on scientific models and assumptions. The actual blood volume of these dinosaurs could have varied depending on factors such as individual size, age, and health. But what about the big boys? Titanosaurs were some of the largest land animals ever to walk the earth, so they would have had a correspondingly massive blood volume. Estimates suggest that a typical titanosaur could have had anywhere between 500 and 1,000 gallons of blood in its body. This is based on calculations of their estimated weight and metabolic rate. To put this into perspective, a human adult typically has around 5 to 6 quarts of blood in their body, so a titanosaur would have had roughly 100 to 200 times the blood volume of a human. Argentinosaurus, another massive sauropod dinosaur, would have had an estimated blood volume of around 500 to 1,000 gallons. This is similar to the estimated blood volume of other titanosaurs. Probably much more than a Brachiosaurus, but it depends on the size of the individual. It all makes sense though. Given their immense size and weight, these dinosaurs would have required a substantial amount of blood to circulate oxygen and nutrients throughout their bodies. So there you have it. Blood by volume within dinosaur species is never going to be precisely known. However, thanks to well-preserved fossils and modern statistics, we can make pretty darn good guesses. If you enjoyed learning about these bloody messes called dinosaurs, make sure to like, comment, and subscribe to Primalia for more exciting content. Share with a friend who loves ancient biology as much as we do. Stay curious.